Good morning, students. Today you are going to learn about some advanced queries in MySQL. In chapter number 5, you have already learned how to create and manage databases and tables, insert records into the tables and retrieve those records by writing and executing some simple queries. But now we are not going to learn about these simple queries. Instead, you are going to learn how to write and execute some advanced queries in MySQL that will involve more than one table. These advanced queries in MySQL will make use of the join operator. So let's start with the join operator. The technique or the method of retrieving data from more than one table is called join. That means if you want to retrieve data from more than one table, you have to make use of the join operator. This join operator can be without a condition or with a condition. The join operator with or without a condition is used to draw information from more than one table. There are several types of joins practiced in databases, which we are going to discuss in the next slide. Next, while performing the join operations, the joining tables may have the same column names. This will create ambiguity and MySQL server will generate an error. To avoid such ambiguities, the table aliases can be used. These are the different types of joins used in MySQL. The first one is the inner join. The inner join is the most simplest and the commonly used type of join, followed by the outer join, the self join, cross join, and lastly the equi-join. Now consider the tables, items and orders in this slide. The table called items has item ID as the primary key and the table called orders has order ID as the primary key. Now the primary key item ID in the items table exists in the orders table but not as a primary key. That is why this column item ID, which exists as a primary key in the items table, has become a foreign key in the orders table. This slide will show you how to relate the tables, items and orders using a foreign key, and also to retrieve the data from both these tables using the inner join. Now check the inner join query. The query is select o.orderID, i.itemName from items I, orders O. Here O is the alias name for the orders table and I is the alias name for the items table. From o.orderID, we are extracting the entries of the column orderID from the orders table using the alias O. And from i.itemName, we are extracting the entries of the column item name from the items table using the alias I. Then in the next line, the condition is specified by the where clause, which says o.itemID is equal to i.itemID. This statement links the foreign key column item ID from the orders table with the primary key column item ID from the items table. As a result, both these tables are related using the column called item ID. Once this query is executed, we can see the output as shown in this slide. Since we are extracting the order ID and item name using this query, so for the order ID as 1 in the orders table, the corresponding item ID is also 1 in the orders table. And when it references to the item ID whose value is 1 in the items table, the corresponding item name is racing car in the items table. That's why we have the first entry as 1 for order ID and racing car for item name in the output. Similarly, for the order ID as 2, the corresponding item ID is also 2 in the orders table, and when it references to the item ID whose value is 2 in the items table, the corresponding item name is Chinese checker. Hence, The second entry in the output table has 2 as order ID and Chinese checker as item name. So, in the same way, we get the third entry in the output table as 3 for order ID and racing car for item name. So, the same query can also be represented as select O dot order ID, I dot item name. From item I, inner join order O on O dot item ID equal to I dot item ID. To put it simply, the inner join is the simplest and the most commonly used type of join. An inner join retrieves the data from 2 or more tables having matching values in the joining columns.